Section 1.5, part 2 video. We left off graphing some absolute value graphs. Hopefully you watched that first video. If not, well, that's fine. I'll show you how to graph some V-shaped graphs right now. So number 4. Now, the only reason that folks tend to miss this type of problem is because they fall asleep on what to do with the vertex. So if you know that this guy that we're graphing has an absolute value, he's going to make this shape. He's going to make a V shape. And if you know this little trick to find the bottom of the V, then the whole graph becomes pretty darn easy. So we need to ask ourselves this question: what is being added or subtracted inside of the root symbol, or inside of the absolute value symbol? And here's a +1. We have to change the sign. So change the sign of the guy inside. What is being added or subtracted on the outside or on the end? Well, the 5 is the guy that's being subtracted. And I'm not going to switch his sign. So the 1/2, if you watch the video, you'd know what to do with it. Part 1. If you didn't, we'll show you here in a second. But either way, I have to graph -1, -5, which is right there. Well, just like slope-intercept form, since we are making straight lines, granted it's a V shape and one goes up to the right, positive slope, and one goes left, negative slope, but you can still consider that guy your slope. So like y equals mx plus b, I can go up 1 and over 2 from my initial dot. I go up 1 and over 2, and I've got the right side of my V. Now I'm going to draw, this is called the axis of symmetry. If you didn't watch the first video, it's where the V shape would mirror over to the other side. So symmetry, good geometry term. Hopefully you learned that in the past. But the point being, if I went up 1 and right 2, then I would have to go up 1 and left 2 to get the other side of the V. Same thing for this guy. So those dots on the right better match the dots on the left as far as the symmetry of that guy that's in the middle. And again, the guy in the middle is called the axis of symmetry. All right, last video, I was too lazy to use the line feature. Oh, this time I am, but you know what? It would help if I got the, that's why I'm not using it. This guy doesn't have a ray. At least I don't think he does. No? Okay. Fine. So I will just make a freehand straight line, which I'm sure is going to be nasty. Yeah, that was pretty good for me. Please don't forget to put your arrows in the end. I shouldn't have said anything. That one wasn't so good. But there you go. So obviously that V is pretty wide. And this would be the reason right here. The 1/2 is going to spread him out. If you're going up 1 and over 2, you're stretching him out a little bit. Okay, so that guy's done. So number 4, again, got to establish the vertex first. Excuse me. So I see nothing being added or subtracted inside. So it would be really tempting to write a 1 here. And I get it, right? You're thinking, hey, it's understood to be a 1 in front of that X. But the question is, what's being added or subtracted inside of the absolute value? And there's nothing being added or subtracted. But there's a 3 on the end being added or subtracted. So don't switch the sign of the guy outside. And there we go, 0, 3. Which is right here. So -3/1. Well, how do you normally count a negative slope? You would go down. So instead of a right side up V, we're going to get an upside down V. Now let's not forget, and we mentioned this in the previous video, if you weren't 100% sure, you could always use this guy, and you could just plug some numbers in, use a calculator, and see what numbers that you get. And I'm telling you right now, the numbers that you would get would be down 3 and over 1, and down 3 and over 1. By the way, we'd like to see 5 points for these. If you do just 3, it's kind of wimpy. Okay, now notice I didn't draw, excuse me, I didn't bother drawing in the line of symmetry this time because I'd like to think that you can handle making that look symmetrical without actually putting the dashed line. But if you feel a need to, if you feel more comfortable drawing that dashed line down the middle, then do it. It's just understood to not technically be part of the actual drawing. And there you go. There's some pretty decent straight lines. Okay, and that's absolute value graphing. So the other type of graph that we need to worry about is called a piecewise graph. So these are a little more intense. I got a bad feeling I'm only going to get one of these in. So if we have to go part 3 video, we'll go part 3 video. Let's look at what it says here in the box. So graph each piece separately. So make an XY chart, and we just started talking about that. For each piece, or if you can determine a shortcut, you do a shortcut. Graph the linear constant parts. Okay, I'll show you how to do that. So really what we're saying is graphing a piecewise function is like doing two separate problems. So again, remember, f of x means the same thing as y. So I'm graphing y equals -3. And I'm also going to graph the bottom guy, which would be like saying y equals +3. But it gets split up. And to me, I'll show you what I feel like is the best way to split it up here in a second. So we're just going to go ahead and graph this like we normally would. So if we said, hey, graph y equals -3, that's a constant function, makes a horizontal line. And we talked about that earlier in the videos. So it'll be right there. And again, unfortunately, I can't use the line feature, and I'll show you why in a second. Horizontal line. So if I was going to graph the other one, y equals +3, well, that's a horizontal line as well, except he would go right here. Horizontal line. Hope you can see that. But you might be saying to yourself, wait a minute, what the heck is this for right here? Well, we'll show you what it's for. So what I like to do is make a dashed line. And it's not the same thing as the axis of symmetry line, but again, we'll show you what to do here in a second. Wherever this number is. So I'm going to make a vertical dashed line right down through my drawing at 0. Okay, now real quick, I'm going to scroll back up here and let's look at what a piecewise function looks like. So there's a picture up here somewhere. Here we go. So clear over here. So you'll notice that there's like a cutoff, like that dashed line I just made. So in other words, this guy does not continue. He goes off to the right and something different happens in the middle. And there would be another cutoff spot here where something different happens. So in other words, like this bottom one, he doesn't extend straight across like that. So there's a cutoff. So let me go back down. So essentially what we're saying is that I got to erase some of these lines. So my orange line is supposed to only be on one side of that dashed line, not the other. And same thing with the blue line. So the question would be, well, which half? And that's where the greater than, less than symbols come in. So if you notice this top one, it says x is greater than or equal to 0, or greater than 0. So where's greater than 0? Well, greater than 0 is to the right. So I want my blue line to only be drawn on the right. So I'm going to erase. Oh, I erased the whole thing. Great. That's okay. So I want my blue line to only be on the right. Now the orange line, I want just to be on the left. Well, guess what? I need the eraser, don't I? And I'll find it eventually. So I want this part over here on the right erased. But again, it's going to mess with me. Doggone it. So this guy right here, if you look up here, it said less than or equal to 0. So less than means to the left. So the orange line would only be drawn to the left. And there we go. So you can see it's cut up. It's in its two separate pieces. It doesn't go all the way across. It stops at that dashed line. Now there is one more detail. And I'm not going to be able to do it because without the eraser, so I'll have to exaggerate here. So notice that the bottom line, this guy right here, had an equal to symbol. So if we have an equal to symbol, if you remember the open and close circle thing, you make a closed circle. But the other one, this guy right up here, did not have an equal to. It just said greater than. So if you recall, those are supposed to be open circles. So I'm going to make an open circle right there. So that's easily fixed. You can just go back and erase and fix. All right, so see if I can do a little better job with number 6, knowing exactly what the features of this thing does. But hopefully that made some sense to you. If not, check out part 3 video and look at number 6. Thanks for watching.